I welcome you to my next lecture. In my previous lecture, we have gone through Tersag's consolidation settlement problems, consolidation settlement theory. So, in continuation with today, we are going to see some of the problems relating to its derivation. So, coming to this problem now, a site is filled by a fill material for a depth of 3 meter as shown in figure. So, determine the consolidation settlement for a clay layer. So, here a typical diagram of a site is shown in figure. So, which means there is a sand layer from ground level. So, there is a sand layer of filled with of 4 meter. So, below which there is an about 10 meter thickness of clay layer. So, then here in this field case there is an water table existing at ground level itself. So, later they have planned to increase the ground level using some fill materials. So, they have filled a bit about 3 meter. So, because of this filling material, so it has an unit weight of 21 kilonewton per m cube. So then they have filled it and compacted it. So now the clay layer which is under the sand layer of 4 meter thickness is already under pressure and consolidated for the years, but now it has recently got filled by the filled materials of unit weight 21 kilonewton per m cube for about 3 meter thickness. So because of this recent addition of the additional pressure, so there is an pressure developed in clay layer that will try to compress the clay layer more. So now the question is, we have to find the consolidation settlement. So as I have already told in my previous lecture, so the clay layer which is subjecting to pressure have subjected for the years and it is compressed for this much amount. Say this is an amount which is got compressed. Previously I have added some more loads, so that some more load is nothing but additional effective pressure which is trying to compress the clay layer furtherly. So that is what the question. So this additional pressure del sigma dash is nothing but the pressure given exerted by this fill material. So we have to find the consolidation settlement. To proceed it, so now we have to look on the data which are given in the question. So fill material, sand and clay layer. So we have to compute the additional pressure which is clay layer is subjected to. Now starting with this, they are asking for consolidation settlement. It is nothing but SP or final consolidation settlement, SF. We can denote it by both the way. So del H by H equals to del E divided by 1 plus E naught is an previously in my lecture before lecture. So I have derived this. In this case, del H equals to, so del H also is nothing but change of height is nothing but the overall settlement that will occur. So when H is multiplied here, del E divided by 1 plus E naught. So this is one of the problem. So they have given height of the clay layer. So this is an height of the clay layer. We are going to talk about it. So height of the clay layer is given, but change in void ratio is thoroughly is not given. So we cannot use this formula. So second one, we have some more formula, that is CCH divided by. So this del E can be written as in terms of CC. So log sigma naught dash plus del sigma dash divided by sigma dot dash. It is an initial effective pressure, then it is an additional effective pressure. So here also E naught is not given, but this initial effective pressure we can calculate for this respective clay layer. Additional pressure we can calculate. CC is not given, so this is the formula also not applicable for in this case. So we are going for an another formula given by volume compressibility MB. So this is volume compressibility, height of clay layer and additional pressure developed. So MB is given in the question itself. So we can write as it is H is an height of clay layer and del sigma dash is an additional pressure. So this is the only formula applicable. So we have two more problems to two more formulas to find the primary consolidation settlement. That is why I wrote it here. So we have to pick a respective formula according to your data. So in this case, so this is known and this is known. So this additional pressure has to be found that So we have an it is like an infinite semi-infinite medium. So it is about filled for a large area. Say in this case the total entire self weight will be going downward as it is, but in case of foundation it will not be like this. In case of foundation, so the load transfer will be like this. So at this place load intensity say q, which is w by a, is as it is w by a, but at this level, so this pressure intensity will be reducing. So at further going down the pressure intensity finally is reducing. It will forming a like a isobar. It is a pressure bulb, but in this case, so the soil is entirely filled over the area evenly, so the pressure will be distributing as it is. So this additional pressure is nothing but gamma into d, gamma d, depth it is 21 kilonewton, so depth it is filled for, so finally we get 63 kilonewton per meter square is an pressure added as an addition over this sand layer. So it is going and acting. So del sigma dash value is 63 kilonewton per meter square. So Sp is given by Mb is 2.2 into 10 to the power minus 4 and H, so here it is given in terms of meter square, so we can better take it as an in meter as well. So it is a 63, so multiplying this finally we get 0.1386 meter. This is going to be a primary consolidation value, but how much time it will take, so we will see some of the next problem. So it is a primary consolidation settlement. If you add 63 kPa of the consolidation pressure over the clay layer, finally it will settle for 138.6 mm. It is a next level problem. So read it the question clearly. A soil sample having a thickness 20 mm tested in the laboratory. So it is about 2 cm of sample is taken and tested in the laboratory. The time required for 50% of consolidation under double drainage is 3 hours. Determine the time required for 50% and 90% of consolidation at the field of the same clay having thickness 6 meter. Assume a single drainage at the site. So as denoted in the question, so there is an clay layer of about 6 meter of clay layer, so from which, so there is an undisturbed sample has to be taken. So they have taken a 2 cm of 2 centimeter of sample and they have tested in the laboratory and they have obtained, so for example U is capital U represents degree of consolidation. At lab 50% of consolidation occurred, T50 at laboratory is 3 hours. Now the height I have taken is effective drainage path D equals to H by 2, which is 10 mm. So drainage path refers how much the effective drainage length it is required to release the water. So H by 2 in case of an double drainage, so they have mentioned it as double drainage, so D has to be taken as H by 2 10 mm. Then in field they are asking for that consider single drainage at the field, so D has to be taken equivalent to H and H is 6 meter. Now for 50% of consolidation what is the time required, and 90% of consolidation what is the time required assuming single drainage. So here it is double drainage. Single drainage or double drainage is nothing but, so there is a clay layer below which if rock present and it is clay, So the clay is fully filled by water. So the water present at the bottom, so if you apply pressure, so the entire water has to travel so this much length to go out of the clay. So all the water present at the bottom, when releases, the consolidation stops. So this is what a single drainage, which means so the entire thickness it has to cross. In double drainage, so clay layer is there, so from the center the water just above the center can go by this top way, and the water just present at below can escape only through bottom. So there are two drainage ways are present, both top and bottom. So that is nothing means that double drainage. So this is a single drainage, only possible flow is towards the top. It takes, so effective drainage path D is given by H, but here effective drainage path D is given by H by 2. So that is in total thickness is taken as H, so we get H by 2. It is an required amount, it is the distance need to be crossed by the water particles. So coming to this problem now, so it is clearly stated that a soil sample of 2 cm is tested in the laboratory, which is taken from the field. So the time required for 50% of consolidation under double drainage system is 3 hours. Determine the time required for 50% and 90% consolidation of the same clay layer having thickness 6 meter. So let us write it like in at lab. So Terzaghi at finally solution he gave that TV equals to CVT divided by D square, and for 50% of consolidation TV is pi by 4 U by 100 whole square. So pi by 4 into 0.5 square, we get the value as 0.196. Here the CV is unknown, we can substitute this, say it is 1 and it is 2. So equating this 1 and 2, 0.196 CVT divided by D square. So here accept CV, so time is 3 hours, and this D square, so at lab the D, so this is at lab, so the D is 10 mm, so we can write it as an 10 mm. So CV is 0.196 into 10 square divided by 3, we get 6.533 mm square per hour. So this is CV value. So here, so the sample taken at the site, using that we found CV value. So this is applicable, this is representing the field, so it is applicable to the field. So coming to this field, for degree of consolidation 50%, we get TV as it is 0.196. So to find out this T50 first, so 0.196, so this can be written here. So CV T divided by D square. So in this case TV has found 53 into T50 is our target, divided by D, here D equals to H, so H equals to 6 meter. So here we found, we are taken in terms of mm, so here D is 6 meter, so let me write this in terms of mm, that is nothing but 6000 square. So to get T50 0.196, 6000 square divided by 6.533, we get T50 as 1.08 into 10 to the power 6 hours. So convert this, 6 hours. So one day have an 24 hours, 1 year has an 365 days. In terms of years we can get 123.2 2 years. So in laboratory, 50% of consolidation to occur, it is taken 3 hours because it is very less height 20 mm. But here T50 of 6 meter thickness of clay for 50% of consolidation, it will take 123.2 years. So we found one case. So we also want to find the T90. So T90 for degree of consolidation 90%. So as I told you in my previous lecture, so when degree of consolidation is exceeding 60%, TV is given by a different formula minus 0.932 log 10 1 minus u minus 0.0851. By substituting all in here, minus 0.9332 log of 1 minus degree of consolidation is 90%, minus 0.851, we get 0.848. You can do it your own. So coming to the same formula, so TV equals to CVT divided by D square. TV I am going to substitute 0.848, CV as given 6.533 into T90, here also a single drainage, so 6000 square, so T90 is 0.848 into 6000 square divided by 6.533, we get the value as 4.67 into 10 to the power 6 hours to get in terms of years. So a day have 24 hours, a year has 365 days, 533 years. So comparing this, 50% of consolidation to occur, it will take 123.2 years, whereas the 90% of consolidation T90 at field, it will take 533 years. So we may have as I have explained in my previous example, we got final settlement as 138.6 mm. So consider this is a 138.6 mm of 10 meter thickness of clay in my previous problem. So the final settlement for 10 meter thickness of clay, it is 138. So like that, what is then 50% of consolidation in means the half of it. Say for example 130, it is about around 69. So 69 mm of settlement, it will take 123.2 years, like that. So this about 90% of this settlement to occur, it will take 533 years. So that is the meaning of it. I hope you have understand. So let me explain here one more problem to give it to you clarity. Coming to this third problem, a 3 meter thick clay layer beneath a building is overlain by an formable stratum and is underlined by an impervious rock. So the coefficient of consolidation of the clay was found to be 0.025 centimeter square per minute. So the final expected settlement for layer is 8 centimeter. How much time will it take for 80% of the total settlement to take place? Determine the time required for settlement of 2.5 centimeter to occur. Compute the settlement occur in 1 year. So simply they have given there is a building. So because of the foundation, so there is a pressure is going down. So below which there is a 3 meter thickness of clay layer, fully saturated clay layer is present. So above which there is a formable strata, which means a sand or a gravel, like that. So below which clay layer below, there is an impervious rock. So this impervious rock, stating that it is a single drainage system. So we have to extract the data available in the question like this only. So a clay layer, so above which there is a sand layer, below which so there is a rock layer. So rock won't permit the water to penetrate, so the only possible way is sand layer. So it is stating that it is single drainage. The coefficient of consolidation, it is nothing but CV. They have given 0.025 centimeter square per minute. So the final expected settlement, they have given expected settlement SF or SP, it is 8 centimeter. They have not talked about any pressure distribution to find out SF. Instead, they found and they have given as an 8 centimeter. So the question is different. They have split it into 3 subdivisions, A, B and C. In first subdivision, how much time will it take for 80% of total settlement to takes place, which means the total expected final settlement is 8 centimeter. So what is an 80% of total settlement? It is nothing but it is around 6 centimeters, 6 or 7 centimeters of the total settlement. So determine the time required for a settlement of 2.5 cm to occur and compute the settlement occur in 1 year. So these are the three different cases. So starting with this, so the given data, height is 3 meter and D is equivalent to height because it is in a single drainage system, and what they have given is CV, they have given 0.025 centimeter square per minute, and final or del H, so both all these three things are same, is 8 centimeter. Now coming to this solution, so time for %80 of consolidation, shortly T80, how much? So we can, starting with the same formula for all the time calculation problem, you can simply start with this TV equals to CVT divided by T square. So to find TV, 0.9332 log 1 minus 2 minus 0.0851. So if you put U as 80% in terms of 0.8, you get the value as TV equals to 0.567. So T8 equals to 0. So here T80, so D square is going here. So here centimeter square per minute given. So 3 meter has to be written in terms of 300 centimeters. So divided by, so D square coming here and CV is coming down. CV value is 0.025. So it is in terms of centimeter square. So here it is centimeter square per minute. So this get cancelled and so minute will be coming here. So the value is 2.041 into 10 to the power 6 minutes. So we have an 60 minutes per hour, 24 hours per day and 365 days per year. So we get 3.83 years simply. So which means 80% of consolidation will occur at the end of 3.833 years, 883 years. So this is a simple case. So in subdivision B, they have given determine the time required for settlement of 2.5 cm to occur. So we can only come to this time factor calculation in terms of degree of consolidation only. So they have directly not given, but indirectly they have given 2.5 at any time. So any time settlement is 2.5 cm. So what is the respective degree of consolidation? So it is an any time settlement divided by total possible settlement. So 2.5 cm divided by 8 cm. So we get degree of consolidation as 31.25%. So through which only we can substitute it this TV. So TV here is pi by 4 u by 100 square u. We substitute 31.25. We get the value of 0.078. So here also TV equals to, for this 31% of consolidation to occur, how much time it will take? So T 31.25%. So time will be, so TV equal to 0.078 into, so D square will be coming here. So what is the D square? The same D, 2.808 divided into 10 power 5 minutes. So it is equivalent to 195 days. It is very simple. So they have not directly given the degree of consolidation, instead they have given 2.5 centimeter to occur. So we can find this degree of consolidation for this total expected settlement. So what is the present settlement is, they are asking for present settlement of 2.5 cm. So we get it simple. Third subdivision, how much compute the settlement occur in 1 year. They have given T as 1 year. So you have to convert this time into minutes, because we are maintaining CV in terms of minutes. So 1 year it have 365 days. 365 days, each day has 24 hours and each hour have 60 minutes. So T1 in terms of minutes. So this is the meaning of T for 1 year. So for before going into this, you have to find the TV value. So for TV in this case, let me write this TV formula. TV equals to CVT divided by D square, and as well as TV we have pi by 4 u by 100 square. When u is less than or equals to 60%, we get the value of around 0.196 for 50% of consolidation. So previously for about 31.25%, about 30%, we get 195 days for 1 year, which means just 365 days. So it may not reach 60%. So that I can use this formula. If suppose, so this 365 is exceeding this percentage, you cannot use this formula. Instead you have to go for this formula, 922 log 1 minus u minus 0.0851. So this may not cross this 50%, so no need of using this. So find this TV value respective to this time. So TV we get CV 0.025 into time 365 24 into 60 minutes divided by D square. So we get TV value as 0.146. So this states that, so usually 50% of consolidation we get 0.196, so it is 0.146. so this formula, which formula is applicable? This formula is applicable. So 0.146 is value. So we are going reverse, u by 100 square. So finding this u, so u will be degree of consolidation, so it is 42.9%. So ST by SF is nothing but u, it is given as 0.429 at any time settlement, which is ST. Here 1 year we get 0.429 into 8 cm. So the final value it will give 3.422 cm. So what I have done in the subdivision 3C is nothing but, for example, in case B, the settlement is given. We found the degree of consolidation respective to the settlement, and substituting this TV formula we get time. Now we have a reverse process. We have time, substituting this TV formula to get TV, and again substituting this in this formula, you get degree of consolidation with this. So to complete this much degree of consolidation, what is then settlement? It has to goes down. So we found at 1 year it is 3.422 centimeter. So with help of this three problems, so I hope you have understand Tesla's one-dimensional consolidation equation. So how to use that to find any time settlement, or the settlement occur in how much years or in time duration. Thank you.